In the waning years of the 20th century, the world was gripped by a phenomenon that would come to be known as the year 2000 problem, the Y2K bug, or simply Y2K. This unprecedented technological challenge would lead to a global effort to avoid a potential catastrophe that threatened to disrupt computer-reliant industries worldwide. The Y2K problem arose from the way computer systems represented dates. Many programs stored dates using only the last two digits of the year, making the year 2000 indistinguishable from 1900. As the new millennium approached, concerns about the potential consequences of this programming oversight began to surface. In the years leading up to the turn of the century, the public gradually became aware of the impending Y2K scare. Companies and organizations predicted that rectifying the bug could cost anywhere from hundreds of millions to billions of dollars. Amid the uncertainty, some people even stockpiled food, water, and other essentials, fearing a computer-induced apocalypse. However, the concerted efforts of computer programmers and information technology experts played a crucial role in averting the anticipated disaster. In the years leading up to 2000, companies and organizations around the world worked diligently to check, fix, and upgrade their computer systems to address the Y2K issue. Then US President Bill Clinton recognized the significance of this challenge and spearheaded efforts to minimize the damage in the United States. As the new millennium dawned, the world breathed a collective sigh of relief when, contrary to some published expectations, few major Y2K related errors occurred. The origins of the Y2K problem can be traced back to the early days of computing, when storage was costly and limited, with memory being at a premium. Programmers devised ways to minimize data usage. Storing two-digit years instead of 4 was a common practice that saved space but had unintended consequences for the new millennium. As the world transitioned from unit record equipment to computer systems, the practice of using two-digit years persisted. Programs were designed to process numbers in their character representations, mimicking the techniques used with punched cards. Few foresaw that these programs would continue to be in use decades later, leading to the Y2K dilemma. Bob Bemer, one of the earliest proponents to publicly address the issue, had noticed the Y2K problem as far back as 1958. His attempts to raise awareness of the issue with programmers, companies, and international organizations went largely unnoticed until the problem reached critical mass in the late 1990s. Despite some magazine articles in the 1970s onwards, it wasn't until the mid-1990s that the majority of programmers and managers began to recognize Y2K as a looming problem. Inertia and complacency led to delayed action, causing many to scramble to address the issue in the last few years of the decade. Experts and analysts warned of the potential consequences, leading governments to set up special committees to monitor remedial work and contingency planning. Although some dismissed the coverage of the problem as scaremongering, it was only after the safe passing of January 1st, 2000 that public fears were fully quelled. Various approaches were used to address the Y2K problem in legacy systems. One method involved expanding two-digit years to include the century, resulting in permanent and unambiguous dates. Another approach, known as date windowing, retained two-digit years and determined the century value when needed. These solutions required extensive testing and implementation efforts. Some legacy databases had their date codes converted to three-digit years, and date repartitioning techniques were employed to avoid modifying entire databases. Additionally, software kits and bridge programs were developed to help address the issue effectively. When January 1st, 2000 arrived, the world held its breath. Reports of Y2K related errors began to surface, but they were generally regarded as minor. Some computer systems were not active at midnight, and issues only arose when they were invoked. Despite the concerns, the world did not witness catastrophic failures that some had feared. Examples of Y2K related errors included glitches in transportation systems, telecommunication networks, and billing errors in some businesses. Although a few minor glitches were reported, most systems continued to function smoothly after the turn of the millennium. In the aftermath of Y2K, the world reflected on the massive effort that had gone into averting the potential disaster. Some critics argued that the problem was exaggerated, whilst others praised the pre-exemptive action taken by programmers and IT experts. The cost of the Y2K remediation efforts reached an estimated $300 billion globally. Since 2000, various issues have arisen due to date overflows and other programming errors. While the Y2K bug itself was successfully averted, similar challenges have emerged over time, highlighting the importance of continuous vigilance in maintaining and upgrading computer systems. The Y2K problem was a landmark event that tested the world's technological capabilities and showcased the power of ingenuity. The lessons learned from this global challenge continue to shape our approach to maintaining and improving computer systems, ensuring a more robust and secure digital future. Thank you for joining us on this journey through the Y2K phenomenon. Be sure to like and subscribe to the James Parker YouTube channel for more captivating videos and fascinating stories from around the world. Until next time, this is your host signing off.